All right, everybody, welcome to another wonderful algebra video. This time we are going to be discussing a little something called distributive property. And you're going to find out all about what that does and what we can do with it. But before we can get on to what the property itself is, we have a little bit of vocab to do. So that should be where we start. Let's start with the vocab. All right, first word on your note sheet here is equivalent expression. Equivalent, you might notice that we have this beginning, EQUI, kind of looks like the word equal. Well, the idea of equivalent is very similar to that. There is something equal about these expressions, and we can see that in the definition, where we have that equivalent expressions are two expressions that have the same value for all values of the variable. So two expressions that will always be the same, even though they may look a little bit different. For example, if we have 3 times the quantity x plus 2, you'll discover that that's the same as 3 times x plus 3 times 2 separately. More on that coming up later in the lesson. In fact, right here, coming up next. The next idea we have is this idea of the distributive property. The distributive property is very useful for what we try doing here in algebra. And basically it tells us that if we have a number multiplying a quantity, something in parentheses, we can split them up to be separate. So you'll notice, for example, in this first part, that we have a times the quantity b plus c. This a distributes to b and c. The a times the b is that it ends up separate from the a times c, but notice that just like in the example here, they were adding, and now in their new form, they're still adding. Notice that something similar happens with subtraction. We have a times b, and then we have a times c, and the symbol between them here was minus, and it continues to be minus over there. These bottom two examples are the same idea, but now notice that a is on the right side of the equation instead of the left. So that a distributing to both places gives you b times a and c times a. These symbols still match, and the same idea happens in this last part. A distributes to the b and the c, and what we end up with is b times a, c times a, and the symbol here in the middle stays the same. That's distributive property, something that you will be using quite a bit in this lesson here today. So, there's a nice colorful drawing showing what's happening exactly. And there's an example of distributive property happening right at the bottom. All right, more vocab. We have terms. These are parts of an expression that are added together. So, in this example here, each of these individual parts, the 3x, the 4, the 6x, and the 2, are all terms. Technically, the 4 is a negative 4, and the 6x is a negative 6x. Those are being added into the whole thing. A coefficient is the number part of a term that has a variable part. For example, in 3x, the 3 is a coefficient. The negative 6 is also a coefficient from negative 6x. Next, we have a constant term, and this is a term that has a number part, but no variable part. In our example that we're using, the negative 4 and the 2 are constant terms because they have no variable. It's just negative 4 and 2. And finally, like terms are terms that have the same variable parts. So, here we see in our last part, the 3x and the negative 6x are color-coded the same because they both have x. And the negative 4 and the 2 are color-coded the same because they both don't have x. So the 3x and the negative 6x are like terms, and so are the negative 4 and the 2. So those are some terms that we want to keep in mind throughout this lesson. All right, so using distributive property. Keep in mind again that a times b plus c in parentheses, this, is the same as this. A good example of commutative property happening. The order switches, but it means the same thing. So we want to simplify 3w times the quantity w minus 7. So here is a perfect place for us to use distributive property. So the first thing we're going to do is distribute the 3w to both of these parts. 3w times w, right there, plus 3w times negative 7. Now notice that in this case, we're sort of treating the negative 7 as one number, which is something you can do. So we end up with 3w minus 7. So we end up with a 3w and w and 3w times negative 7. Next, we're going to multiply those out. 3w times w ends up being 3 times w squared. And then the 3 and the negative 7 will multiply together to make negative 21. So we have minus 21. The w is just sort of there for the ride. So we have 3w squared minus 21w there. And honestly, we can't really do much past that. So that is our answer for that question. Next example. Simplify 2x minus y plus 5z times negative 4. Remember that having negative 4 over here at this end just means that we're going to distribute still. So we distribute here, here, and here. Now when we do that, this is what we end up with. We have the negative 4 multiplying each of those parts. We have negative 4 times 2x. And then we're adding negative 4 times negative y. And then we're adding negative 4 times 5z. And now it's just a matter of doing those multiplications. Negative 4 times 2x gives us negative 8x. Negative 4 times negative y, two negatives multiplying, give us a positive, and we have 4y. And then negative 4 times 5z gives us negative 20z. And we can't really simplify anything here because we have different variables. That's x, that's y, that's z. So this is our final answer here. Next example. Simplify negative 2a minus 6c minus 7a. Well, one of our multiplication properties that we learned recently is that when you have a negative in front of something, it's the same thing as saying you have a negative 1 in front of that. This is very important for distribution because now we know that we can take this negative 1 and multiply it here and here. And when we do that, we're going to discover what our answer ends up being. So we have negative 2a, hasn't really changed. That negative 1 times the 6c is going to make it become its opposite, which is negative 6c. The negative 7a will become positive 7a because that's the opposite of negative 7a. But notice that in this example, unlike the previous one, we have an a here and an a here. We can combine those together because they have the same variable. It's called combining like terms. So we have the negative 6c kind of left over, but we can take that negative 2a and that 7a and combine them to make 5a. And when we've done that, when we have 5a, now we're ready to write our final answer as negative 6c plus 5a. So what we did was we took this, and we combined them into this, which is reflected in our final answer. Next example, find the perimeter and area of the rectangle. Well, if it's a rectangle, and we know that the length of this side here is 4, then the length of this side here is also 4. And we also know that the length of this side will be 7 minus 3y. As far as perimeter goes, what we're going to do is we're going to add all the sides up. A few ways to think about it. You could either just multiply each of the side lengths, 4 and 7 minus 3y, by 2, and add those together. Or you could separate everything out individually by side, as is done here on the right. Either way, you should end up getting the same answer, and as long as your math is all good, that answer should end up being correct. Either way, you should end up getting 8 plus 14 minus 6y. We can combine like terms and combine the 8 and the 14, and that'll give us 22. The negative 6y, we can't do much with. So that's where we end up in either case. As for the area, remember, area of a rectangle is length times width. Very important for us to know here. The length of the rectangle is 4, and the width is 7 minus 3. Notice that this is distribution now. So we have 4 times 7, and 4 times negative 3y. 4 times 7 ends up giving us 28, and 4 times negative 3y gives us 12y, minus 12y. So then we have the area of the rectangle, at least the best answer that we can come up with. There it is. All right, 2 more examples. Translate, then simplify. All right, look at all these underlined words that are going to be important for our answer. 4 times, well, what does 4 times mean? We know we're definitely going to need a 4 involved, so let's get that in position. The sum of 7 and w. Well, if I remember correctly, sum means plus, and we need the sum of 7, so 7 plus, we need a w. But we need just one w at that point, don't we? So let's just add that in here because I don't see a w by itself. There it is. And if we want 4 times that whole thing, we're really going to need that to be in parentheses. All right, there we go. Decreased by twice the difference of 2w and 10. Well, decreased always to me means minus. So minus twice the difference of 2w and 10. Well, twice means 2, and we usually have parentheses after that. Twice the difference of 2w and 10. Difference again means subtraction. So 2w minus 10. And it looks like we have a few extra symbols left over. That's fine. Move those over. And then we have to simplify this. 4 times the sum of 7 and w decreased by twice the difference of 2w and 10. All right, distributive property first. 4 times the 7 and then 4 times the w. So let's write that down. Plus 4 times w. And then here we have minus, and then here we're doing distribution again. Minus. We're distributing the, or we'll just say plus negative 2 times, or sorry, it's positive, 2w plus negative 2 times negative 10. All right, 4 times 7 is 28. 4 times w is 4w. Negative 2 times 2w is negative 4w. And negative 2 plus, times negative 10 is positive 20. We can combine like terms here. Positive 4w and negative 4w cancel each other out. They actually are inverses of each other. So they end up equaling, in total, 0. On the other hand, 28 and 20 do add up to something. They add up to 48. And since 48 is the only thing left over, that's our answer. All right, last question. You are buying candy for a birthday party. Swedish Fish cost 99 cents per bag, and Milk Duds cost $1.25 per box. There will be 11 total people at the party. Write an equation for cost C as a function of number of bags of Swedish Fish. All right. Well, if we were to do that, we would know that the cost is going to equal the number of bags or boxes. We need that to be true. It's going to be related to that at least, times the cost per the bag. So our total cost is going to be, we knew that each bag of Swedish Fish was 99 cents. So the cost of the Swedish Fish bags is going to be 99.99 times F, which will be the number of Swedish Fish bags. But then we need to add in the number of Milk Dud boxes, and that we know is $1.25 per box. And we know that there are 11 boxes or candies total. So if we take the number of Swedish Fish and take that away from 11, that'll be how many boxes of Milk Duds we have left to get. So there's our function. To find the cost when you buy 4 bags of Swedish Fish, we just plug 4 in for F. We get 0.99 times 4 plus 1.25 times 11 minus 4. 0.99 times 4 is 396. 11 minus 4 is 7, so we have 1.25 times 7, which is 875, and those together then give us a total cost of $12.71. So this has been a little bit on distribution. Hope you found it helpful, and now you are ready to try out some homework problems. So good luck.